In this video, we're going to look at another example of 2D 3D trig, and this is quite a classic one. And so what we've got is we've got a triangle, and step one, we always want to try and fill in the missing angles first before we do anything. And so let me just go bossies with that. So it's 90 degrees A, so this will be 90 minus A. There's a 90 degrees and a theta, so this will be 90 degrees minus theta. If this is 90 minus A, then the next door neighbor, angles in a straight line, will simply be 90 plus A. It's a cool little trick. And then if this whole angle is theta, but the little one is A, then this little sliver here would be theta minus A. And so now I've got all my angles that I might need. So step one, finding the angles, is done. Step two, I find it's helpful to try and work out the common line. And so in this case, the line that joins the two triangles is CD. So we might be trying to dive into that first. Step three, I look at the triangles I'm working in. And so I've got the entire triangle, but realistically, I'm probably working more with the bottom little triangle, which is a 90 degree triangle, so I'll use SOH CAH TOA, and this top little sliver triangle, which is not 90 degrees, so I'll either use sine or cos rule. And if I have a chance to default, I'll probably default to sine rule if I can, because it's a little bit easier, but I might need to use cos rule. And so because they're wanting AD, and I've got all the information in this triangle, let me just start with this triangle and let's take it from there. So prove AD is equal to this. That's a bit too much of a headache to even begin thinking how to get that. But because we filled in so much as a discipline, we go straight to AD. I like to put what I want on top. So AD, the side, over sine, the angle opposite, should be equal to the other side over sine, the angle opposite. And all of these angles are just waiting for me because I filled them in. AD, I'm going to take this that's at the bottom to the top, so it will be H sine theta minus A over, my brain's buzzing. Whenever I see a 90, I recommend to my students to highlight that, to remind yourself it's a co-ratio. And so sine will actually change into cos of A. And just like that, you've got what you needed to prove. Then they ask, calculate the area of ADC if 17, H is 17, theta is 58, and A is 23. And so that should be as simple as us just subbing all of those in. And so let me just start with what I've already got. AD would be H sine theta minus A over cos A. I don't need to do any shifting. I can just punch that in my calculator and I get 10,59. Then you may ask, why did I work that out? Because I've got side. Here would be my other side that I've just worked out, and the angle in between. And a reminder, when you're working out area rule, you always need side included angle side. And so let's again dive straight into area. It will be half the one side, which is H, times the other side, we've just worked that out, times sine of the angle in between, which is 90 minus theta. And when I punch that in my calculator, it spits out my final answer of 47.7. They didn't tell me centimeters anyway, so I'm just going to say units squared. I hope that you found that helpful. If you did, please like it, subscribe to our channel, and share this with your friends. Thanks a lot.